Right, now looking at the chart graph, y equals to tan x from 0 to 360 degrees, that is the domain again. Now, of course, we need to start by the table again. Now, let's analyze first here. Let me start by saying, okay, now looking at the graph, there you see the asymptotes there again. So why do we have the asymptotes there? Now, if you say sine tan of x, tan of 90, what do you get? Let's start by asymptote. What tan of 90, what do you get? You get error. That's why we have this asymptote. Is that clear? Tan of 270, what do you get? That's why we have this asymptote, this lines of the asymptote here. And remember, the asymptotes, they are the lines that the graph will not touch again or cross. So the graph if the asymptote again. Fine. Now from there, looking at this part, let me start by saying, okay, now the period of this graph, is how much? 180 degrees again. So now there is a point where this graph is changing the shape again, all the way from here to here. Can you see that now it's changing the shape? So when you change the shape here, it means this one again it's a quarter. Can you see that? Yeah? Can you verify that it's a quarter? And this one will go again to another quarter. So it means from here to here is a what? It's kind of a if you say it's a quarter, it's fine. But let's look at it's a half cycle. Can you see that? Agree to move to quarter. Then order this graph is to then you must make another quarter again. Then that will be what? Half cycle. Now again, let's look at here. From here up until here. Can you see that here is another quarter? The third quarter and the fourth quarter. Then we know that the fourth quarter stage make what? A complete cycle. So can you see that the period of 180 we get a complete cycle again? So it means in turn we get what? A period being what? 180 degrees. So now let's plot the graph again using the period of 180 again. Regular graph, you must get the scale again. So what will be the scale? The scale will be the period divided by 4, which is the number of quadrants again. So now what is the period of this graph? The period is 180 degrees divided by. So what do you get? What a graph from 0. So guys, 45. From 45 for add 45 here, 90. Now if you need to use calculator, then that's why you will say the step must be 45. If you press a calculator again, the step must be 45. Then now you show all the values again. I mean, 0 and 0, turn of 0 to 0 again. And the turn of 45, you get 1 again. 45, that's why it's a malo 1. But now, turn of 90, you get what? Error. Now, from 0, 45. From 45, the graph must change. Maybe approach the asymptote, but you will never pass the asymptote. So the way it changes direction, but it will to the asymptote. Okay? Now, we will move. 135, turn on 135 line. It shows that minus 1. Where turn 180, 0. Where from 0, graph will change from 180 from there to the asymptote, but it will never touch the asymptote. Moving like that. So from there, if we say 225, then you get what? 1. That's why at here, now from that 270, then the graph will just continue like that again. It will never pass this asymptote. You get what is happening with chart. And then, why is it error here? Remember, tan for grade 11 again. Tan of theta equals to sine theta over cos of. Now what is cos 90? Cos of 90 degrees. Good guy. Cos of 90 degrees. Good guy. 0. Now what is anything divided by 0? That's why we get an error. So for grade 11, that's why we divide when we divide by 0, we get an undefined, okay? Which is an error. That's why we get the asymptotes there. So now let's go to now we've done with the period again. Let's go to the amplitude. What is the amplitude of this graph? What is the amplitude of this graph? Yeah? What is the amplitude? 1. What is the amplitude? 1. Upper amplitude right here, 1 again. Do you have the amplitude here? It means the amplitude is not there again. The amplitude of the domain is not there. Like 1 again. So now, if you say 1, I don't know. Now give 1 again. Now let's go to the range. What is the range? What is the range of this graph? Yeah? Remember, range is the starting from the minimum to the maximum. Okay? So what will be the range here? So what is the range? Y is an element of real numbers. Again, it can take all the values of 1. So that will be the range. So negative to infinity too. But be careful, because you must say y is an element of what? Negative infinity to positive infinity. Now if you write the square bracket, the roof has complete 0. If you write bracket, we give you complete 0. So be careful if you want to use this method again. This one is much safer. Just write y is an element of real numbers to get your 2 marks again. So that is only for tan again. For tan, you write that. That will be the range. Of course, the domain is given again. The domain there. The domain is simply what? Right, now we need to be careful. What is the domain? What is the domain? X is an element of real numbers, but X cannot be what? X cannot be error. At the line of the asymptote, we don't have X again. So meaning X cannot be 90 degrees again. Anyway, X cannot be agree error more. Because to la value jora also amala sinus domain. Because only value X more the graph does not exist again. A graph is a koma the asymptote mori 90. I joy agree graph I torano yapi. Mo esa torano ra na limit mo ya cut. One again. So our cultural that value does not exist. So running for 270, for 90 and 270, the graph does not exist again. But X can take what? Everything there. But let's be careful. Let's say X, let's not everything again. X is between what? X is between 0 degrees to 360 degrees. But mention this one. X is between 0 degrees to 360, but not X is equals to 90 and not X equals to 7. Let's not X is an element of real numbers, okay? Because if I at 367 and then it at 0. But inside this interval, this value here, X cannot be 270 degrees. So I want again. X should not be 90 degrees. So I want again. So that now we have a domain in that case. Is that clear? So now we have the range, we have the domain, we have the period, and then what is the equation of the asymptote here? What is the equation of the asymptote? Equations of asymptotes. Because of null asymptotes, again. Equations of asymptotes. What is the equation of this line? What is the equation of this line? X equals to 90 degrees. That is the equation of the asymptote. X equals to 270 degrees. These ones are the equations of the asymptote. But when you say domain, these are equations of the asymptote because that's where the graph does not exist again. So we must cancel them when you get to the domain. So the line that is vertical like this, we know that is x equals to a certain value. Again, the line that is parallel to the x-axis like this, we know that is y equals to a certain value. Yes. Yeah. I said period is the frequency that is taken to complete a cycle again. So when graph na a complete cycle, rate on what number? We started from 0, and then I said from here to here. What do you see? That is a chord again. From here to here, it means that will be the second chord again. Yeah. Now from here, from 1H to here, what do you see? From here to back to there, what do you see? So how many quarters are there? 1, 2, 3, 4. So quarter for the a complete cycle. Then that's why the period of turn is what? 180 degrees. Or at 180, or relay a complete cycle. For it to change, no, what is the original period? We start from the original. It can change according to the graph, yes. Now, yes. What do you mind? On the domain, here. You are saying this part. I'm saying, what is the domain? The domain is given here. Okay? Is that correct? Are we together here that the domain is given? But inside this domain, x is between this one. Okay? Then now, but inside this domain, what happens at 90? What happens at 90? The graph does not exist. Because that's what linear here, you got fitted this value. And then at x equals 90. Therefore, inside this domain, x should not be 90. When I say x, you can't say what I said x is not equals to 90 degrees. Why? Because the graph I exist. That's why if I the turn of 90. So it means the graph there does not exist. So it means at x equals 90, we should cancel it. The domain is not there. I just want to know about part of the domain. So x equals to 270 degrees. Why 270? At 270, the graph does not exist that way. Can you see that? So that's why when you write the domain, you say x is between 360 degrees and what? 0 degrees. But you say therefore these ones must be only. If you can one, then you must write them that show that at x equals to 90 there is an error. It's an asymptote. At x equals to you must also cancel this one again. At 270 the graph does not valid. So rather you must cancel this. Now this is the domain of the term. Is that clear? So that will be the domain of the term. And then so I hope it's clear for the domain of the term again. Now, is it possible for the graph to be what? We have a period of 360 again. Now, what is this one? It's the period of the original graph again. Now, if they come and say now f of x equals to again tan of what? Not related to the amplitude and the shifting again. But this one is for grade 11, but we can learn that. If I say half of x, can you see that? Yeah. Now the value that is here, the neighbor of the angle is going to affect what? It's going to affect the period again. Now when you want the period here, we'll say okay. Now the period of the original graph again. What is the period of the tan? Thomas, so what is the period of the tan? What is the period of tan? 180 degrees. Is that correct? But now, what is the period of tan half x? Now remember, when we want the period, after we say the period of the new graph, new period, again, new period equals to what? The period original, again, we can say original period divided by what? We can say frequency. What is frequency? This number there stands for frequency. Why frequency? Even graph rotate guy so that it can make a complete cycle. So rotate guy half of what was the original again. So to make that arbon. Now what is the answer here? It means the new period will be new period period tan of half x. I say tan x. So what are you buying it? What is the period of tan original? What? Keep guy 180 degrees again. What is the frequency here? The number that is close to the angle. Keep guy 1/2. Now if you press your calculator and say 180 degrees, now of course it will be multiplied by 2. That will be what? 360 degrees. So the period of tan half x is what? 360 degrees. But you must start from the original again. So oral for grade 11 and 12, if they put something before the angle, that is the frequency again. So it's going to change what? The period of the graph. So if the question comes to say what is the period of tan half of x, because there is change on the frequency. So it means that our period we know what I need. Yes, you do the same with cos. So if I say the cos of 2x, what will be the period of this graph? So you will say 360 degrees divided by what is the frequency? 2. What is the what? 180 degrees. So the period of cos 2x is what? 180. So if question answer what is the period of cos 2x, you are going to write 180 degrees. So I also want to 360 because it's no longer the original graph. The one again. 360 again, the original graph again. And then the original one. As long as this step at the frequency, then even if you got cos 2x plus 3, what is the period? The period will remain 180 because on the next to the angle, I still have 2 again. So the period will only affected by the coefficient of the angle. So if nothing there, it means it's 1. So it means I'll say 360 divided by 1. Then that will have the same period in that case. Now when I say the period is 720, hence I said if I say the cos of half of what? Of x, what will happen here? What is the period of the original graph? 360 degrees. Divided by what is the frequency? Divided by 1/2. Sorry for that, 1/2. Now what is this one? That is the same as 360 degrees multiplied by 2. What is that? 720 degrees. Can you see what happened? Now we say the period of this graph is now 720 degrees. So it means in 720, that's when I will make a complete cycle. With 720, running 360, half the second. Yeah? Running if the graph was side from here to here at 180, maybe I'll have a turning point and at here, can you see it's a half second? Because the graph must make a complete cycle at 720. So right now, this half of 720 is 360. At 360, I'll have a half second. So right, just know that the period we're talking about the values that will take to make a complete cycle. So that's what we have by the period. So that's why it's also important why when you're going to do the scale. So you take the new period divided by 4. Is that clear? When you're doing the scale of this graph, when you use calculator, you say new period. Also not period divided by 4. We say new period divided by 4. Then we get what? A scale. Like one again. Take note of that. New period, like here. Right now, I start to know about period. New period divided by 4. Then we have what? Now we have the scale. Okay? In that case. So that's it. Is there any question? So it means we exhausted the graph. Let's check one for time and see what's happening. For turn, how do they ask questions on the turn? Tiwe ematomotan. Barring, consider the functions function y equals to 2 tan x. Make a neat sketch of y equals to tan 2x equals to z. Provide the whatever, but draw the graph. Alright, we now already know that the scale. What is the scale here? You look at this one. What is the scale? What is the scale? 45. Why? Period. The period, original period, divided by. So what is the period of time? Divided by. What is the scale? 45. Alright, I'll do my calculation to 45. Okay. Now, alright, I got tan level something. Very worrying. Tan x to guy, tan 45 to guy. Tan 45 to guy. Now, what over 1 times what? 2. What will you do? Change the direction at 1 as a change it 1. You change it 2. Why what? Is that clear? I want to start again. So, meaning, if I do the first part and I have what? 45 degrees. I get something on the scale. We come here now. 0, 45, 90 degrees again. Rather 90 again. I think 2 again. So, right from 0, if you make 1, make 2. What graph at 45, give guy 2. So rather my graph will go like this, from there it will move like this. Can you see that? But it must just show a nice curve there, okay? Or change it from there. What? From there, from 45 over 130. Is it 135? From 9 to 135 degrees. 135 degrees is the Malay, use the Malay minus 2. It will be somewhere there. Then you draw the graph like this. At 180. It will be what? 0 again. After 135 to 180. 180 degrees equal over 0. From there, 0. From there, the graph will go like that. So again. Draw a nice graph. Then from there, if it's a chola pele, you can feel like 180 again. Because it's a chola pele, 2 to 5 degrees. And then at 2 to 5 degrees, the Malay 2. Then it means it will be something like this. And then from there, it will be what? 270 degrees. From there, it will be what? Something like this again. I think 2. Can you see that? From there, you continue that again. Up to 360 degrees. I will start again. Now, if the graph of f of y equals to 2 times x is reflected about the x-axis, write down the equation of the new graph obtained by the reflection. That is simple. What will be the answer? F of x will be minus 2 times x. Can you see how simple they are? Now let's check another one. If they will try to trick us. Here's another one. We'll draw it again. You'll do that. Minus tan, of course, you shift your graph. you have to shift your graph. This one is not for turn. Turning moshi. Turning she will play about draw. What draw is in a low challenge about so about draw it on. Mogging him on turn. For a draw. How this time also do not draw it on. Great head. You must know how to draw the graph of turn because in most cases you are draw. Right, we exhausted the graphs. Is there any question based on the graphs? So, what I go to feel it means you can at some point do it on your own again.